He's from mathematics department of Warsaw University. He's one of the very few mathematicians there that knows some physics.
And so, real problems, not with some abstract mathematics.
I know Gabriel from a seminar about geometric control theory and how to operate with a cat. He's a geometric control, okay?
Pytanie jest tylko, czy jest zgoda na przeprowadzenie doświadczeń nad zwierzętami.
I think that the experiments he will be showing on there will be some movies here. The experiments were performed in USA. That's not our guess.
Okay, thank you. So I'm going to talk about this phenomenon of the falling cat. So at first, if you think about it, you can think that it's impossible for a cat to land on its feet if we drop it with legs up. And it's possible because the cat is not a brick, it's not a rigid body, but it can move. Okay, so during my talk, first of all, I will tell you something about physiology of the cat. It will be.
But even if it would break, it would just fall on the.
I mean, the something which is not clear in your statement is the word dropped. There is a famous case of dropping down the piece of bread with the butter on one side. It's not movable, and when you drop it, it in most of the cases fall on the butter or the jam. But and this has been investigated experimentally, and we know that it's due to the unprecise meaning of the word drop. So the same.
But let's focus on.
Okay, I know this phenomenon with bread, and I know the explanation, and it's something completely different because. Okay,
Let's go to the cat.
So first of all, I will talk about physiology of the cat, and then I will explain mechanically or control theoretically how it's possible on certain model, a very easy model. So maybe we begin with a movie of the falling cat. It's a movie from the 19th century, the first movie about the cat. It's from 1892 or something like this. It's slow motion, as could be. Okay, and now another movie, this time contemporary, actual slow motion. So you see that you can do that without a problem, even if it's dropped from half a meter or something. And here we have a movie of the cat which is falling in the free-fall aircraft. So we assume that there are no forces acting on this cat. And here you see that he had a problem, see? But actually, in my opinion, the problem is that he don't understand what is going on because he doesn't know where it's downward, so he don't know what to do. But probably he nevertheless is able to flick. Okay. So maybe some facts and myths about this phenomenon. So what are the strengths of cats? First of all, cats have very flexible backbone. So, for example, they have 30 vertebrae. Humans have only 24. So it means his backbone can bend to much more places. And also, in his backbone, there is more mobility than in many other animals. For example, in human body. As you see, he can bend rather more than normal human. Okay. Next, cats do not have color tone. I translated because I assume that some of you may not understand this word. And this is for even more flexibility because we have a collar bone, we can't move our arms too much in this direction, and he can move it more. So probably it will be important during the landing, where amortization is very important. Third, cats have excellent vestibular apparatus for good spatial orientation. Vestibular apparatus is some kind of apparatus in a brain.
When?
It's not when. It's something before when. No, it's a. It's a kind
in
of.
Polish language it's called inner ear.
No.
Well, I asked this question Henryk Skarżyński. And if there is any person in this world who knows everything about the ear, then Henryk Skarżyński. And this is his translation, so I...
Yes.
Maybe it is about human ear.
Well, before he touched a human ear, he must have killed infinite number of cats, rats, and other things. Let's don't discuss this, right?
Nie jestem specjalistą, ale wydaje mi się, że w internecie jest to tłumaczone jako właśnie aparat przedsionkowy.
But interesting question is how does it work? It's inertial, gravitational sensor, inertial sensor.
No, it works in this way. It's a pipe in which there are a lot of hairs and there's a liquid inside. And this liquid moves during the... No, because these hairs must...
Maybe this is acceleration.
Yes,
Inertia and acceleration
yes.
sensor.
Something like this.
Everybody has a smartphone one. So.
I'm not sure.
Let's try to drop the smartphone. It doesn't have a color bone. It fulfills 3 conditions out of 4, so it should be proper.
Okay,
So basically, did everybody try to drop a snake?
I don't know.
Yeah, because the snakes have more vertebrae and they don't have collarbones.
But there is no up and down.
But there is no legs.
Why?
It's symmetric. It's actually
Have you ever seen a snake?
Yes.
Well, it's totally unsymmetric. It
Yeah.
the shape of a snake is completely asymmetric.
It's moving us away from the...
It's like saying that the humans are basically cylindrical, or a famous spherical model of a human.
Okay, so cat has much better spatial orientation than human, for example, and many other species. And next, and maybe this is the most important thing, cats have innate writing reflex. So this ability to to flip very quickly. As you see during the movie, he do this almost instantly. He doesn't have to think about it. He just innately do this.
But the ability of not thinking is so common between humans that they should have been able to do this.
Mówię po
Much better.
angielsku, żeby dobierać precyzyjnie słowa. It's rare. And it appears at 3 to 4 weeks of age, and at 7 weeks it's just perfect. And it's, well, scientists says that this is innate. This is not something that cat is learning from his or her mother. Okay? I don't know how they can figure it out.
Well, it's interesting how it has developed, because I don't think that evolution tried to optimize just following cats.
Yes.
So it had to develop for some completely different reason. Maybe because it jumps in complicated terrain over branches or things like that.
It's the other question. It's the question: how do certain animals lose certain abilities? We don't have any reason to practice this kind of a behavior. Therefore, we use that part of our brain for other purposes. It's not known that the cats can do differential calculus. Some humans can do.
So, what is for certain not important in this phenomenon is tail. You know that the tail of the cat is important in many situations in cat's life. But during the free fall, the tail is not important. So there's a...
How do we know it?
Cats from island man.
Because
There are
I
cats
want
from
to say
island man
that
without tail.
This is like with the dogs illegal. We cannot base a science on illegal practice.
No, they are naturally born without tail. These monks. Yes.
Even humans are born
There
with
is
a tail.
special breed of cats at island of Man, which is called monks, and these monks
they have no tail or have only a stub of tail, and then can flip, even though they have no. So it seems that the tail is not important during this. Okay, so maybe about the flipping technique of the cat. So here you have a picture. So it's us doing this falling. And first of all, cats must bend in the middle. Then actually he tie the front legs and extend the rear legs. So you see just to rotate his head faster than his back. But it's not important, I think, from a mechanical point of view. It's important because he wants his eyes as fast as it can be to point down. So I think this is the result. Then he rotates in this position until his head is pointed downward. Then tuck the front legs and extend the rear legs so that the back rotates the same angle, roughly. And then extend the front and rear legs and relax if he has enough time to amortize the impact. I will show you another movie and you will see exactly that the cat does.
I think the line before the last should be tuck the rear legs and extend the front legs. It is clearly visible on the third photograph from below. Just cut and paste mistakes.
Yes.
Particularly the second and the fourth line are identical.
Yes.
No, well, that's a different. I mean, it first accelerates the rotation of the upper part, and then accelerates the rotation of the lower part.
The instruction of the left was just cut and paste.
Okay, and here you have a contradiction to the title. It's not always land on their feet. But actually, they are often 90% of cats. Okay, so
Hmm?
So there is a maximum somewhere.
yes, there is a maximum. So here you have a connection between number of stories from which the cat is falling and the number of injuries per cat. Injuries. Of course, the injury doesn't mean that the cat dies. You can have injuries, but it can be fixed. So it occurs that if the cat is falling up to 8 stories, 7, 8 stories, on average, there occurs more injuries. But then, if the cat is falling for more than 8 up to 32 stories, then on average these injuries are there are much less injuries. And explanation is the following one. When the cat is falling from more than 8 stories, then he has much time to prepare himself and relax to land on his feet and make less damages during his flight from less stories. Okay.
Falling is acceleration or according to stocks?
Yes, because
It's constant velocity.
when this is yes, because when he reaches approximately 8 stories, then yes, exactly, and then velocity is roughly constant, and he doesn't have to spend time and effort to control the body and can relax the muscles. And according to 90% of cats survive the fall between 2 and 30
Is it so that above the 8th floor the air resistance to the objects like the cat, which is fairly complicated due to fur, okay, it's not the linear velocity dependent, is going and start to fall with the same velocity. So it doesn't count like
yes.
That's what he said.
Like a parachute.
For a human being, it's 200 kilometers.
Yes, yes. Yes, exactly. So roughly there is is such a velocity. It's not exactly 27 meters. Okay, so
that simply
here
shows
you
that
can see a movie.
the fur of the cat is extremely important.
Yes, of course.
And that it wasn't mentioned in this dynamic.
Well, I don't remember, but I read somewhere the data about human fallings from buildings, and the terminal level is much lower. I don't think it's a third floor or fourth floor or something like that.
Because the velocity, the terminal velocity is much higher.
Now I will tell you about the mechanical explanation of this phenomenon on the blackboard. Here we have roughly what is happening. But I will tell you about it in more details. Okay, so maybe we should turn it off. Okay, so I will tell you about the so-called Kane share model of the cat. This is the model from 1969. It answers Kane share. And in this model, the cat is composed from front and rear. So we have two rigid bodies. Once I try to draw something like cat. Okay, so this is cat. I assume that at the beginning his legs are stretched upward and he has a tail. Okay. And we assume that here is a joint. At first we assume that this joint is universal, so it can move in every direction. Okay. But also you can assume, for example, that the backbone should not be broken during this during the movement, so there are no rotations. Okay, but this will be the next. So first of all,
Is this the point is the center of a mass of a cat? Or?
yes. Obviously. This is the center of the cat because I assume that, for example, this is the center of the rear and this is the center of the front. So it must be here. And actually I will coordinate this system in this way. So,
And this is physiologically sound assumption. That
I'm not sure.
Because I thought that the cat is clearly not that built. There is a head which is...
Yes, I said that this is a model and this is the model of
They are responsible for this.
the guys. And
So the model consists in two rigid bodies plus a certain junction, yeah, which has to be specified precisely what is forbidden, what is possible.
Yes, at first everything is possible.
Do you assume that these two rigid bodies are the same, or
Yes. Yes. I will assume. So I assume that they have the same mass, but the mass is not important here.
So it's a parity.
tensors are also the same. So I assume that this inertial tensor has a symmetry, so this is I1, I2, but what is important, these are inertial tensors.
So the axis of symmetry just along the curve.
Yes, exactly. So right now, I assume that this is the front or rear of the cat, okay, and this is the first axis. So one, and there are two others.
Something is much bigger than.
Well, I'm not sure if it's much bigger, but
they are not equal.
But they are not equal. Well, I think A should be less than B. I don't know.
It is because it's.
Yes,
yes,
yes.
yes.
But okay, but
What about this theorem in classical mechanics that the rotation around one of either maxima or is unstable? The axis on which
The rotation around
the axis on which the inertia, eigenvalue of the inertia tensor is maximal is unstable. Or maybe it's stable, I don't
It is
remember.
stable around the maximum and the minimum.
Maybe
And unstable.
So in this case it will be stable around both.
This
right?
I think does not apply here because we have two rigid
I
bodies.
know, but I just want for a moment to consider each one separately. Take a knife and cut it up. Sorry for that. It's a gedanke, let's put it.
okay, now obviously I want to first of all consider consider the principle of conservation of momentum. So it's easy if I assume that the center of the mass is in the beginning of the system, then I assume in the free fall there's only one force which I can neglect, that is acting on the cat, and in the system where the cat is falling, this center of mass doesn't move. So this principle gives me nothing more than
So in other words, you say that gravity is only for orientation.
Yes,
Otherwise,
gravity is only
dynamically it doesn't.
Yes, exactly. And then I have a principle of conservation of moment of momentum, angular momentum. And to compute this angular momentum, I must rotate the front body and the rear half of body, and then add this moment and actually also add the summa compared with the fact that the center of the mass is not in the center of the jump.
But in this assumption that you are in the co-moving frame, so to speak, there are also inertial forces because it's not an inertial system. In addition to,
well,
you have the Coriolis force, you have the Fugger force in this frame. It's a non-inertial frame.
But he simply totally neglects the gravity.
No, I understand.
Neglects
but what does it mean? That we assume that the system is the center of mass.
Yes, but
This is
constant
a
velocity.
Maybe with constant velocity.
No, I assume, actually I assume
So
that...
acceleration is...
Yeah,
Yes, yes.
It's minor.
Okay.
Acceleration is
Yes, I neglect all the forces. Just the kinematical, I think.
So his question is it possible only by kinematics to understand what this cat can do?
Okay, so
Actually,
So it could be the fall from the floor which is higher than it.
Yeah.
Then it's constant velocity.
but the constant velocity is not necessary, because if it's free fall, then this is inertial frame. Free fall is inertial frame. Free fall is inertial frame.
Like always.
okay.
But it is not a free fall.
Yes.
I mean, these movies have shown that this is not a free fall. If it was a free fall, it would have never been a terminal velocity. So there's a contradiction in the statement. If there is a terminal velocity, it's not a free fall.
Yes.
So I mean, you make a decision what you are talking about.
We are mathematicians. There are no forces. Gravity is only to tell you where is down. End of the story.
You just throw a cat from 1 meter over the floor. We are very far away from terminal velocity, and in addition, it is all in the constant gravitational field, and I think the gravity can be added without any problem, because the momenta of forces will balance each other in the center of mass.
Except that the important part of the cat is its ear. And its ear reacts to the gravity. If you will just cut the head of the cat, it would never make any turns.
But
falling
in
down.
this model,
That's the solution. The cat is doing it by its head. The question is not in the rigidity of the body or something, but in what is the reaction of this animal brain.
The question was about the free fall frame. And free fall frame is inertial frame.
Yes.
Period. So there is no inertial velocity.
Yes.
It's not an inertia.
Yes.
Yes.
No, it's
Constant velocity.
So their axis was still there without this.
And they are still free fall.
Yes.
What are those?
So I assume that this axis, this system with still gas, this coordinate system, is a system connected with Earth. Okay, so it's fixed. And this system without still gas are connected with
The body.
with the body, so with this coordinate. Okay. So we can rotate this body in the system. And now if this inertial tensor for the body, this is the first body actually. Okay. Now it's like this, then we must take a change of coordinates of this coordinate according to this coordinates. So from this picture you can easily see that this is something like this. Well, I assume that zeta is this angle. Okay. Rod. Okay. No, sorry. Okay. And in order to
minus what goes with sine.
So there will be
Tak,
minus.
minus przy sinusie.
No. Change the orientation.
Dobrze jest, bo on zmienił E3 na minus E3, będzie minus 1.
Yes.
W dodatku jeszcze jest odbicie.
Exactly. Okay, then I'm supposed to do 1, 2, and this matrix I will call A, P. Maybe in English it should be A, F.
Przód, tak?
Okay, and then by this I actually okay. Tensor of inertia of the front of the body in this fixed frame is given by by transpose, which is actually the same, and we can compute, and this is important, that this is A cosine square zeta plus B sine square zeta A minus B sine zeta cosine zeta 0. This is the same as here. A minus B sine zeta cosine zeta. And here is A sine square zeta plus B cosine square zeta 0, 0, 0, and here is B. Okay. And then I do the same with the rear of the cat. So this time the body is oriented in this way, and actually I will assume that the angle is the same, zeta. Organized this way. And then this AT, so the change of coordinates given by the following matrix: cosine zeta, sine zeta, minus sine zeta, cosine zeta, 0, 0, 1. So here I assume that this EQ is equal to EQ field, and of course this is E1. And then this inertial tensor of the back is equal to, okay, it's roughly the same. The difference, so this is the same. Sorry? No, this is the same angle. I assume that this is the same angle.
Numerically is the same.
Okay,
Okay, numerically.
I assume that it always
It's numerically
always more
symmetric. Okay, so here you have B minus I sine zeta cosine zeta 0. So this is the same as here. And all the other entries are the same as previous. Okay. And now this Kane and Sher model, actually the picture there is like that. So we have this A1 killed. assume is a center of mass of this cat. Here is a joint. Okay. The center of the mass is of back and front. Okay, that is important. And now I assume that these axes are tilted by zeta. Okay. And because we want to...
So can you tell me what this cat can do? What each part of the cat can do, really, now?
For instance,
Or a priori,
can he make such...
and can he rotate along the axis?
Yes.
Yeah, along the axis.
No, about its own.
So we assume first of all that, okay, we can do any move of this joint. It's a general joint, so it can rotate in any direction. But we always, if we rotate it, then we always move this frame so that it's directed in this way, that the center of the mass is in the center of the coordinate system, and these two angles are the same.
So the blackboard also rotates, so it always...
Yes. Okay, so, but it's important that here we have another two dimensions. So it's important for us to measure what is happening in these two directions. So we assume that, for example, these legs are pointed at, for example, 0 angle, and so this is the leg, okay, and we measure from this leg to the angle between this leg and the blackboard. Okay. This is the and this angle is denoted by beta, and the same for the rear. So this angle is denoted by gamma. So we have three angles. And of course, if we assume that the cat has this shape, then we can rotate the whole cat by the certain element in SO3. Okay, so we can reorient all the cat. And in this way, by taking three angles and which actually give us one element in SO3 and another element in SO3 which reorients this cat.
Yeah, but the question is, what are the controls? What does the cat do? What are the forces that the cat can exert on these parts? For example, can it increase the angle psi, or whether there is a possibility of move around the... So
actually, right now we assume that he can do anything he wants. So, yes, he can...
because not all the forces can be internal. Some of the forces, if I take the cat and turn the cat around, then it's not the solution.
Yeah, but model applies to the moment when you let him fall.
Yes, there are no external forces. So
okay.
There is only...
So that restricts the possibility of certain motions.
So he only will apply conservation of angular momentum.
Exactly. I will not speak about forces and about, for example, which muscles.
Ah, I see.
So
finally,
he wants to see what conservation of angular momentum allows to the cat to do.
yeah, but so finally, how many control parameters has the cat at his disposal?
3.
Namely, those
Gamma,
psi, beta, gamma.
This is 3.
Aha.
This 3.
Okay.
And now the point is that if these 3 are changing, then we must know how the whole cat rotates in the space. And this conservation of angular momentum will tell us. So right now we must just compute this angular momentum and assume that it's 0. So I recall that so this is the angular momentum of this cat, where this you have, and omega p field is, first of all, maybe I will write everything down and then tell you what is.
So there is capital So this total omega is at a certain moment given. Yeah, it is just given this capital omega.
Yes, so this overall rotation.
Yeah, overall.
Rotation.
So
Yeah, and it is, suppose it is given at a certain instant of time. Yeah.
well, it's not given. This is the angle
Yeah.
which the body will rotate. If we move the body, if we change these angles. Okay. So it's not given in the way that we steer these angles, we steer these velocities, this for example.
The controls are beta, C and gamma, and this omega is resulting movement.
So in the figure you plot, the omega is 0.
Well,
In this configuration, omega is...
well, if you
What is omega?
Okay, I want to explain.
Can we draw this arrow, curved arrow on the blackboard indicating where is omega?
No, because omega is around the...
Because this
Okay,
last rotation
That we
takes
also can draw.
Okay, maybe
Goes
I'll
in one
explain.
side and goes out. I mean, everything can be drawn on the blackboard.
Okay, I will try to
Nie,
explain
bo
that.
tablica się okrąży.
Yes, exactly.
Well, that also can be drawn.
Omega p is a change of angles beta and zeta connected with the front of this cat. Okay? So if we assume that we can rotate in this direction, and we can rotate this cat in this direction. So then, if we want to know what is the contribution of this rotation to this angular momentum, then we must change this angle by this change of coordinates, and then act on this angle by this.
So, can I think about this omega as an angular velocity of rotation around E2 tilde axis? Or not?
Yes.
This is the rotation, the flipping rotation, the flip.
Yeah, that is the
velocity of
rotation which...
Yes. So this is the rotation about this E2 tilde axis.
Exactly. So one move is
So this, the geometry is exactly like what is called the watt regulator in the steam engine. The only difference is that the vertical axis, we turn it upside down, right? And the regulator water, this is the watt regulator. The only thing is that we turn it upside down. It's usually suspended on the top, not on the bottom, but that's not the problem. And the other axis which we have difficulty to understand is that this axis on which the whole device is built can also rotate in a plane which is perpendicular. Everything can be drawn nicely on the board.
But there is still
did you ever took apart the watt regulator?
Yes.
It has these metal balls, and they also can rotate around this
But the geometry is different because in watt regulator the rotation is around E1, not E2.
But we have two heavy bodies.
No, but geometry is different. In this direction, not in this direction.
You're not listening correctly. There is a vertical axis on the plane, on the blackboard, right? And this is let's for a while think this is this metal bar on which the watt regulator is built. Then you have two arms of it, and in the real watt regulator they also can rotate around it.
No, because they are.
They can rotate. We can go to the museum of
But
the
watt regulator works due to the centrifugal force.
Yeah, well, because that's how it works, but the geometry is identical. No, you have a fork angle. This is this opening.
But it rotates in this direction in watt regulator.
But in this, so that's what I said, and this rotates in this direction. Yeah, well, so it's broken. It can fall apart.
Look at it's not right. They cannot move this way because they are tied to this metal which moves.
But usually the watt regulator is built like this. Then we have a metal bar and the two heavy balls on it, and you move these balls on it, and they also can rotate around it.
This one they can rotate, but it doesn't matter.
Yeah, but that's precisely what the cat is doing.
There might be something here which may rotate, but it doesn't matter. This degree of freedom doesn't interact with anything else.
Co tam jest? Kwadrat? Nie, co to
tak. This L is the distance from the joint to the center.
jest? Okay, anyhow, so when you apply this angular momentum conservation, that's what is the result for the omega.
Then you obtain something like this.
No, but angular momentum conservation is usually an equation which says that the time derivative of angular momentum is zero, not that the vector is zero. The vector is just a constant. Anything.
But the one solution is that n is equal to 0.
Yeah.
Right?
We assume that at the beginning,
angular momentum is zero.
Yes. That which clearly is what comes to the question. I hold the cat and I drop it. And the drop it is what kind of angular momentum I'm assuming. Where did I open up my fingers symmetrically or something? And that, of course, is all what is important.
Okay, this is a model. Very simplified model.
Another way of looking at it,
Yes, but still it
from
is
the
interesting.
mathematical point of view, is that we have two asymmetric tops.
Right.
And each top separately has a well-determined dynamics, and there are equations that govern this. The only extra constraint is that they are fixed at the point F. So this is a motion of two tops with an extra constraint.
Right.
Okay, so maybe,
So we are happy with this omega 3 equals 0.
yes,
But
this means that
Because there is no rotation.
So what it cannot do this.
yes, cannot rotate in this way. And now we can assume that he will not break his bone.
To nie może zrobić salta. Bo to omega 3 znaczy, że nie może zamienić głowy z ogonem. Czyli to zrobić salta nie może.
Actually, not correct. He cannot do that. He cannot do this instantly.
But does this follow from the...
If I consider
This is
control
an,
system,
this is an extra condition, omega 3
No,
equals
no,
0.
no. It comes from
it comes from the equation.
It comes from the initial condition that there was no initial angular momentum.
Because if I assume
Of course, this is an
gives
assumption.
me
Of course, you
a
may-
connection
Yeah,
on certain manifold,
but what makes E3 distinguished? Why the direction of E3, which is in the horizontal plane, is distinguished because there are many E3s in the horizontal
Because we
plane.
drop the cut properly. You do it very
Every
carefully.
is perpendicular to the plane of the cat.
Yes.
It is distinct.
Perpendicular to the plane of the cat.
it's always perpendicular.
Assuming that the cats were not playing.
So actually he can rotate. I mean, if you assume that he can break his bone a little bit, you can compute that this distribution is so-called bracket generating. So actually you can move in any direction. This control system is controlled. Actually he can rotate in this direction, but he needs a lot of time.
Yeah, okay, but what is the conclusion?
So the discussion of this one.
Maybe that if you assume that
If you make a device that you can control the angles, theta, gamma, and psi, then you can make it happen.
yes, and if you assume that this backbone cannot bend, then
Which simply means
So
that
it
he
goes
does like
opposite.
that.
Yes, opposite.
so this is this assumption. Then actually you obtain that the only zero part is omega equals minus half.
Musicie ukręcić.
Assuming that e squared is alpha, for example.
Po prostu ci go
Then it should be possible to make a mechanical Karen test.
And so he actually can move on and rotate only with respect to this axis. So this is exactly what
So so the conclusion is if he rotates along its own axis in opposite direction, then he can rotate along the two axes, right?
yes.
But this condition B dot plus gamma dot equals 0 means that he does
No, no,
what we have seen on the
gamma dot
movie.
is not equal to 0.
No, but I said B dot plus gamma dot equals 0, which means that they are opposite. This means there is that.
Coupling between
Yes, yes. It was precisely what we have seen on the movie.
Yes, but they are rotating in opposite directions.
Right.
Okay, so that's
Can this be tested experimentally?
On humans,
No, not on humans, but you can... No, but one
this
can...
model.
Yeah, one can relatively easily make a...
Yeah, but that would assume that you drop the cat bending the cat legs, because the cat has legs. The construction of this model is extremely crude and has no association whatsoever with the physiology of the cat.
Yes, Łukasz, that just says everything. Can we have a movie now? After we have learned this, can we have a movie and see it?
Yes.
It exactly is what follows from those equations, as far as I remember.
Because the head and the hind legs rotated in the opposite direction. So this
Ja myślę, że do prądu trzeba włączyć.
Nie, wszystko jest dobrze, jest włączone.
Jest włączone?
No, this.
o tak, ten.
Puszcza ręce. Oczywiście.
O, właśnie.
To o to chodzi.
Beta kropka plus
Gamma
omega kropka,
kropka zero.
gamma
Czyli ten głupi kod wie o tej omega 1 i chce wyzerować.
Tak.
Yes, because otherwise it would rotate around
Tak.
and wants to minimize. Once more.
Jeszcze raz ten.
Once more.
Widać, że taki prosty model rzeczywiście uchwycił to, co jest
Bardzo
istotne.
prosty model.
O. A,
Tak.
tak jest.
Oprócz tego, że on ma nogi i to nie są dwa
Dobrze,
Ale oczywiście to jest bardzo uproszczony model.
To są modele,
Ale
żeby
pewną
uchwycić istotność.
Discuss in English. Once more. Can I see it once more?
Tak samo jak model Bora atomu nie zawiera nam shiftu, ale uchwycił istotną cechę.
W tą stronę, a to...
Jedno w tą, a w drugą. No.
There are many other movies on YouTube, so we can
No, but this is interesting because for us it would be difficult to try to imagine that you are falling, you are jumping and move legs in one direction, but in another direction I can't
But
imagine.
now you know. Now you know how to do it.
But astronauts do it in completely
No, how it
what and they can also rotate in space in completely different and much easier way, just to rotate with hand.
Yeah, that's true.
So it is not necessary to do it in this way.
Sure, but it's interesting physiology because what wonders me is that it was almost certainly not built into this cat in order that it can rotate, right? Or not rotate.
The fact is this, but the problem is the cat rotating its legs in order to or it does everything with the legs, and that is why how it comes.
This is of course true because this was only a kinematic
That's
model.
right, there was no
It
dynamics.
was only kinematic, and how does he obtain this omega? It was not.
That's a different
That
question.
is of
Yeah,
course
of course,
because
of course.
it's
The dynamics is another
No,
story.
but dynamics was on the previous movie when he first stretched the rear legs, then vice versa.
but here it has